So today my talk is about towards agentic recommender systems in the era of LLMs, large language models. So I will focus on introducing how the recent advancements of LLMs are reshaping the agent AI and also their influence on the recommender systems community. And also I will share some of my thoughts on some interesting research questions and problems maybe worthwhile exploring. So today's talk is not highly technical, but to this end, I hope you still find it useful and can spur some.
Please keep on going.
Okay. Can spur some new research ideas. Okay. First, let's take a look at some examples of recommender systems. I hope I can use this slide to convince you how important the recommender systems is. So the recommender systems, the typical scenario for recommender systems actually stem from the online shopping scenario, like the Amazon, eBay. So when we do the online shopping from these e-commerce websites, as users, we always get some suggestions from websites like, you may also like these items, right? To encourage you to explore some other items. And also recommender systems have also been widely used in the entertainment domain, like the music recommendation on Spotify, movie recommendation on Netflix, and not to mention the short video recommendation on TikTok, or the video recommendation on the YouTube. And another scenario application for the recommender system is the people of interest recommendation. So when we use the Facebook or some other social media website, you are always recommended to some people like you may not know at the current moment, but you might be interested in connecting. So this is called the people of interest recommendation. Has been widely deployed in the social media websites. And another case is the Q&A website. So as a computer science student, I used to post some questions on Stack Overflow, or you maybe post some other different questions on the Quora and some other Reddit, some other Q&A website. So behind the website, there are always a kind of similar recommendation engine. So they will always recommend the most appropriate expert to handle your questions. So it's kind of like the matchmaking. Okay? But recommender systems, have far beyond these domains. One of the recent successful applications for recommendation is in the medicine. Domain. So in the traditional way, the patients who have diagnosis with the same disease or the same cancer, for example, so they will be treated with similar treatment. But by integrating with the recommender systems, so the patients will be treated personalized, given their different biomarkers, like the different pathological patterns or the different responses to the treatment. So in this way, so the treatment would be more effective and sustainable. And another domain is the high-stake application is the cyber defense. So the recommender system have been deployed in some organizations to automatically and proactively generate the mitigation course of action given the potential cyber threats detected. So this is all some other recommendation applications that you may be not aware before, but actually have been deployed in reality. So recently, I also came across another interesting example for recommendation. It's used in the law enforcement. So the judge has been using the recommendation systems to help them to decide if this defendant should be detained or released. So this is another example. So you can see lots of opportunities. And in my opinion, I think recommender systems is one of the most successful machine learning tools in the real-world applications. So that's why I think why I spent time to talk about this. So one is to try to explain why it's important. Another reason is I have been working in this topic for more than 15 years. So when I started to do this topic, it's a very small community, but in the past decade, I have been witnessing how the community grown significantly, right? So you came across many publications from the top venues, far beyond the PDD, CIRES, and even penetrated to Europass and SLR and CVPR, right? Okay. So that's why the community keep growing. The community keeps growing. So that's what brings us more opportunities and chances. So then let's take a look. What is recommender systems? Actually, at the abstraction level, to be simplified, the goal of recommender systems is to learn a utility function that can predict the user's preference towards a list of items. The inputs for the recommender systems contains usually in general, contains three types of data sources. One major source is from user side, including the user's feedbacks, like the explicit feedback, like the rating score or the review written by the users. And the implicit feedback, like the click-through data. Also users' preference, like the historical behavior trajectories. And the demographic information, like the user's gender, income, and the education background, something like this. And also the social connections. So the social connections is always leveraged to develop some kind of social recommendation system. Right? So another source is item. So mainly is about the description of the item characteristics and the features, as well as the correlations across the different items. So the third data source is the context. So it's more dynamic, usually refers to the temporal information, spatial information, environmental status, and also social norms. For example, especially this context information is especially important for the mobile recommendation. So when you try to find a restaurant, so to have dinner with your friends or a colleague, so if you, based on your historical preferences, so if the mobile recommender system didn't consider your current location, for example, I'm traveling and I'm currently in Brisbane, so it's not reasonable for the system to recommend a restaurant in Sydney, right? So the context information is more important for the mobile scenario. The outputs usually is just the real value number to quantify how much the user like this item or not. So we know the recommender system can be solved and formulated as a machine learning problem. In general, it can be formulated as a classification problem. So this is a simple binary classification scenario. So to just simply predict if the user likes this item or not. And you can definitely design some multi-class classification scenario as well. So, and also it can be formulated and solved as a regression problem. For example, to precisely predict how much the user will like this item or not, to quantify the preferences. And in recent years, to better model the interactions between the users and the recommender systems, it also be treated as a sequential decision-making processes. So because the user continuously interact with the recommendation system and continuously and send the feedback to the system, and this is form like the feedback loop. So this process is treated as MDP, Markov decision processes, and can be solved using the reinforcement learning algorithm. And given the current studies, usually it has three categories of solutions using the reinforcement learning. We know reinforcement learning is not a new concept. It has been used to solve lots of different problems in the past decades. But recently, with integration with the deep neural network, so the reinforcement learning become more scalable. and it can model the very large action and the state space in recommender systems domain. So I quickly walk through the current major solutions about the DRL for recommender systems. The first one, the figure A, shows the classical setting is on policy, reinforcement learning for REXs. You can see the policy is updated at each time step with the streaming data between the users and and the systems. And figure B shows the policy of policy. So in this way, you can see the difference. So experienced replay buffer will be integrated into the whole pipeline, and the policy will be updated by learning from the streaming data as well as the buffer. Okay. And recent years, so to better make use of the readily available benchmark data sets in the recommender systems community, like the Amazon data sets, the Yelp, some Chill, the lots of benchmark data sets, the offline IO become more popular. So in this framework, you can see we will have the offline data set. So this data set is assumed to collected and generated from an unknown behavior policy, pi beta here. So during the training, the policy won't interact with MDP at all. Just after fully trained, so the policy will be deployed and fine-tuned. So one advantage for this approach is we can leverage lots of different offline data sets, right, to maybe partially tackle the data inefficiency issue or some training unstability, but also cause some issue for the distribution shift. So while I talk about CIRES here, just lay some kind of foundation when I discuss the alignment later. So you will find there are actually some shared techniques and solutions can be transferred from one problem to another. So that's the transfer learning principle. And then we just from the temporal perspective to quickly overview the evolution of recommender systems. So I just listed some keywords here, but it's not cover the whole evolution at all. So just to show kind of the trajectory, how recommender systems evolving in recent years. The earliest generation of recommender systems are mainly the approach of content-based. So that's why in the earliest, I think 20 years ago or 30 years ago, so recommender systems is only the subtopic of information retrieval in the community. So the content-based approach, the main goal is to calculate the similarity between the target item and the historical items liked by the same user. So you can see it's a kind of multi-stage. First stage, calculate the simulator, and then develop some efficient method to retrieve, right? To retrieve the most similar ones. So this is a typical approach for information retrieval and filtering. And then, but for this content-based approach, one of the major drawbacks is so only consider this single user, right? So it cannot leverage the collective intelligence among all the users. So that's why in, I think around 2000, so the collaborative filtering became one of the most successful approaches for recommender systems. So the core idea is to leverage, to find the like-minded users. For example, find users just like you, and find out what items they like, and make the recommendation instead. And about 10 years ago, 10 years ago, around 2013 or 2014, deep learning have been widely used in the recommender systems. Two of the major advantages for deep learning is one is, so the deep learning can help us to develop an end-to-end differential solution, right, without feature engineering or feature extraction or some multi-stage solution. And another way is, deep learning used to be called as representation learning. So it can help to to learn very powerful and expressive representation and introduce more inductive bias in the data types. And after that, we head into the LLM age. So everything becomes LLM related. So, and after that, I will spend some time to talk about LLM, and then we transition to the agent AI. So let's first take a look at the LLM for RxSys. As we know, the LLMs, so I mainly refers to the GPT series. I know some of you maybe work on familiar with BERT, but here we only focus on the generative GPT, not the discriminative BERT models. So the LLM actually are pre-trained using the internet scale data set, right? So this is to pre-train. So that's why it is equipped with the very comprehensive world knowledge and the human values and also the almost everything. So about the human behaviors, human society. So that's why it built a good foundation for the LLM to generalize across different domains. I know if some of you work on the recommender systems, maybe you are familiar with the cross-domain recommendation, right? So our focus is if the recommendation model can be generalized, from the source domain to the target domain. But with LLM, so maybe can just save us a lot of time and effort. And the second advantage for the LLM for RxSys is it has the better and the more powerful user modeling, especially when we're dealing with the multimodality data. And also, the LLM can comprehend and understand the very complex queries from the human. So that means it has the better explainability and the interpretability, right? So that's why lots of work to just level up the recommender systems with better explanations using LLM to explain why the recommender systems recommend these items to you, right? Towards some responsible AI or ethical AI something. Okay, so this picture, so it's not so the work I listed in this talk, almost not from my group at all, just some of them from my group. So I listed here because I thought this might be important inference for you after the talk. You maybe would like to read it through. So in this survey, these users summarize the current studies about LLM for RxSys. Usually we have to think about the two questions when we try to integrate the LLM into the RxSys. The one question is where to adapt the LLM in the whole RxSys pipeline. This is the different placement to adapt the LLM. Use LLM as a feature engineering or feature encoder, or directly use as a ranking function, or enhance the user interaction, or just put the LLM as a central controller to oversee the whole pipeline of recommender systems. Another question is how to adapt. As we know, so it's not practical for us, maybe I think in most cases for us, to pre-train a large language model from scratch, right? Maybe most of the current work focus on fine-tune the LLM. So that's can be divided into two different directions. One is fine-tune the LLM by freezing some parameters and change some others. Another way is totally don't need to change any parameters. We can use some prompt engineering or some in-context learning, right? So this is kind of to categorize the group of the current studies for LLM for RxSys. So for the agent AI, because agent AI is not a new concept either. Agent AI refers to the entity that can perceive the environment and make decisions and generate actions, right? So before LLM, so the agent AI usually need to be carefully designed for some domain-specific task. And it's hard to be generalized and maybe also for short in a good adaptability. But with LLM, it can be easily extended with other, for example, some external tools, and also good at planning, reasoning, and the instruction following. So this is make LLM as a good candidate and a good foundation to build up a more versatile and adaptive agent AI. So that's why the LLM-based autonomous agents becoming, gaining more attention. You can, so from the 2021, so you can see many of the agents have been proposed and developed in the different domains, from the traditional general agent like a web agent, personal assistant agent, to the embodied AI agent, right? So this is show the this survey just so they only include the work in 2023, but recently there's more agent work that have been proposed. You can try to find out. Okay, so generally agreed by in the community. So the agent, LLM-based agent, usually need to have some shared components, like the planning module, memory module, action, and tools. So the planning usually to equip the LLM-based agent with self-critic, self-examine, and then improve itself. Okay? So, and there's a lot of different conceptual frameworks have been proposed by researchers and from academia and the industry. So for today's talk, I only briefly introduce two types of conceptual framework I thought very inspiring. The first one was proposed by, I think, from Fudan or some research group from China. So you can see from this conceptual framework, it contains, the agent contains three major modules: perception, brain, and action. The core component is the brain. So actually, the LLM is more acts like brain. So they have the memory module, have the knowledge base, and also has the decision-making module. It can conduct the planning and the reasoning. So here is an example. Say if the user posts a query like look, and along with this picture, say look at the sky. Do you think it will rain tomorrow? If so, give the umbrella to me. So this is a typical embodied AI task. So the query and the inputs will be sent to the perception module, and with the multimodal processing, and will be converted to the LLM understandable embeddings or some other representations, and send to the brain part to process. For example, by analyzing the features from the image, and also try to get some users' current this location's historical weather history, and look at some knowledge base, and so the series of decision-making processes, and then they will send to the action module to generate the corresponding actions. For example, if this is the embodied AI with the robot arm, maybe we'll find and pass the umbrella to the user. And if the totally virtual scenario, maybe just output a text or a multimedia outputs, right? So this is, and then the process will be repeatedly, so to form like the feedback loop. Yeah. So this is one conceptual framework proposed a couple of years ago. And after that, I think this one is very famous, right? So this is proposed by Stanford University. So we can see some shared commonalities with the previous one. It also contains the planning and the learning, memory, and action. And they also insert a combination part. I would like to emphasize one major difference of this one from the previous one. you can see the dashed line here. The dashed line here. So the action generated by the agent will directly influence the learning and memory part without the feedback from the environment like the previous one. Okay? So this is the major difference of this one from the previous work. And so that makes this one maybe more suitable to some multimodal embodied AI tasks. Okay. And yeah, after introducing two very popular conceptual framework, so this is two recent models about agent AI design. I try to just quickly introduce because they are laid foundation. You will find in some other domains like Rexes and also some CV tasks. They also follow the similar design principle like these two. So let's first take a look at the left one. It's called reflection. The agent contains three major parts: actor, evaluator, and self-reflection. So the actor, its responsibility to generate the action, and it takes the state observations and also the previous trajectories to form like the short-term or long-term trajectories. And the evaluator is mainly to try to assess the output of the action actor module, like to output like the reward and output like reward or scale and sent to the self-reflection module. For this one, from its name, you can tell it's more like to self-analyze and by taking these reinforced signals from evaluator to improve itself. And then after self-improved and send it to the long-term, to store as a long-term memory, aka the experience, and will be used as another input in the next episode of that in the actor. Okay? So you can see this is formed like the continuous loop as well. So during this process, the agent will learn how to improve from the feedback and to better handle the task at next episode. The right one is called the React. It's a quite famous one, also proposed by the first author, Shunyu Yao. So, and one of its major innovations is combine the reasoning traces with the actions together. So it's like it's a purely prompt-based pipeline and method. So a prompt in the React usually contains the reasoning trace, human-written actions, as well as the observations and in responses to the environment as well. Here I did a very quick comparison between these two different frameworks. So you can easily see which framework maybe you need to refer when you deal with some real world problem. For example, they have the different focus. Like the reflection, you can see it's a kind of the self-reinforced improvement process. So its focus is to better handle the long-term strategic maybe tasks through the self-reflection. And the React framework is kind of like to the reasoning and action to interact, interleaved. So that means maybe it's more suitable to real-time reasoning and action. And from structure, the reflection framework is a typical cyclic structure. The React framework is more like you can start as a sequential structure. So for the reflection, just like it's more adaptable to over the long term, the long run. And the React, if you need some context-aware and very highly interactive task, maybe React would be a better choice. The learning mechanism, so both of them can be solved by the reinforcement learning. And but for React, you sometimes maybe you don't need you can just design some heuristic rules, right, to guide the learning. So, for examples here, like strategic planning and personalized learning agents, that maybe the reflection could be more suitable. And for the autonomous, like the self-driving car or the robotic, like especially for the robotic navigation or some task, maybe React would be more suitable. But it's not just a clear boundary between both of them. So let's put it in the context of the recommender systems. Yeah, you can, based on the vanilla version. So for example, if we want to develop some kind of the recommender systems, it's focused on the long-term user engagement. So maybe reflection would be a good choice, right? But if I know some students, maybe some of you work on some conversational recommender systems. Right? So it's during multi-turn conversations to make recommendations to users. Maybe React would be more suitable. So it's so you can after we understand how the frameworks work, maybe we can just contextualize them into the different problems. But definitely, this is just the basis. So we are free design the different frameworks to fit our problem. Okay, finally we can cover the agentic recommender system because it's lots of associated with lots of background. So let's just spend some time on the background introduction. So based on our recent exploration, currently there are two different ways to develop the agentic recommender systems. The first is to use the agent as mainly for the user simulator, like to to design the agent to mimic the user behaviors, right? So in this way, you can consider that maybe to augment the data. I think it's similar with the data augmentation, right? To help us to better understand the user behaviors and then to improve our model. So another way is to directly use the agent as the recommender systems. So you can see this is a basic, so some existing studies, they develop their agentic recommender system based on this workflow. Let's first look at how the agent currently is used for the user simulator in the RecSys. Basically, there are two different approaches. The first one is handcrafting. So it's in this way we assign the agent with different personality, different profile information and attributes, and then prompt the LLM to generate the behaviors. So it's a typo, should be. So this way is flexible, but labor intensive, right? You need to manually design the agent, one by one. So this is the example here. So we assign agent, say you are a male, and your personality is humorous, and your age is 30, or your education degree is PhD, something like this, and then prompt the LLM to generate the behaviors. It's very, very flexible, but it's hard. It takes lots of labor cost. And another way is auto-generated. So in this way, we design some generation rules. For example, so how to generate how to compose different attributes. And how to use this profile information, something like this. And then use some, pick up a small number of agents as a seed agents, and then bootstrapping to generate. In this way, it's very scalable. You can easily to generate a large number of agents, right? But it also has issue is like, because it's automatically generated based on some seed profiles. That means maybe it's hard to control and processly track. And here I would like to have some brief discussions on the agent as simulations here. These are two questions I think very interesting. Yeah. So the first question is from an individual's agent's perspective, because we're just wondering if this agent behavior, because it has been tailored to fit some specific role or personality, right? So does it also reflect the dynamic behavior patterns, just like the real humans, right? So that means, because for our real humans, even though you are outgoing people or you are very highly analytical people, but with different contexts and domains, maybe we will make different choice accordingly, right? So not just so in this way, how the agent can adapt to the dynamics while still maintaining the specific role assigned to it, right? So it would be a very interesting, yeah. So another one is multi-agents, because we try to, yeah, so use one agent to, in many cases, one agent is used to, yeah, to simulate one user's behavior. So between the agents intercommunications and the conversations, so do the agents exhibit the consistent personality, conditioned behavior during the interactions with other agents? Here is the example. So when we do the group project together, some students may be very analytical and strict, but maybe the others a little bit more spontaneous. But during the interactions, if the people who are very analytical will influence the people who are spontaneous to make a compromise and to collaborate these things together. So how to influence with each other? Yeah. So this would be another interesting question, maybe to study in the multi-agent environment. Yeah. So how to control and trace the interactions between the different agents, and how to model the evolution of the interactions. So I think maybe, yeah, if you are interested, maybe can dig a little bit deeper. Yeah, so it would be very interesting. Okay, then let's take a look at the other group of current studies, agent as rexes. So this is one typical work. So you can see in the middle, this is the basic framework. We can see some similar modules, like the self-inspiring. It's similar, not similar, it's inspired by the self-reflection. And also the memory part, it contains the personalized memory and also the word knowledge. So it's like the people-specific memory, or the people free and shared some kind of commonality. And the tools, so because once the model is deployed, that means unless you use some continual learning or some other technique, otherwise the model's parameters are kind of fixed. So the LLM can just seek some external tools to help to complete the task. So in the tools, you can see this work, they deployed the expert model and the SQL and the search tool, right, to help them to maintain the whole performance of recommender systems. And this is the general bedrock. Can support the different recommendation tasks, including the rating prediction, direct recommendation, sequential recommendation, review summarization, and also explanation generation. So you can see, I would like to emphasize the explanation part, because we know people always want to know, so why does AI recommend this product to me? So this can generate some human readable explanations using LLM. I think in some, like the recommendation in banking or finance or the healthcare, maybe the recommendation is more essential and important than any other domains. This is another work. I pick up these two representations just like to show the different design principles maybe you can find a little bit inspiring. For this one, it's a human-centered approach. So the agent sits in between, and you can see the solid line. This workflow. First, the agent will take the original generated recommendation items, and then will retrieve to the personality library and to filter out from the original list and send the filtered items to the users. And then turn around from look at the dashed line. So the agent collects the user's feedback and to further process as some to preference learning and evaluate if how the feedbacks can be divided to fit the different contexts, and then select the appropriate feedback to the recommender systems. And then also is also used as a kind of the privacy control, because privacy is always an issue for recommender systems, because the recommender systems are based on mining from the digital footprints of users. So to some extent, some people just concerned if their private information have been leaked, right, to be maybe used by some other purpose. So this design principle maybe thought for this agent sitting between can help work like the controller, so to manage the whole process. But you can also clearly see, so the agent sitting in between maybe can also cause some problem like the bottleneck as well. So this is some kind of open questions we can further explore. Okay, for this I list current, so far until 2 weeks or 1 week, until 1 month before. So this is existing work about the RegSys, agentic RegSys studies. You can download the paper and read the details. So last, I would like to share some of my thoughts on this topic. So there's a lot of open questions and emerging questions around this exciting topic. So here I only talk about these questions, and hopefully you can find a little bit inspiring. The first is the multimodal agent. So it's associated with multimodal LLMs as well. For the recommender systems, especially for the video recommendation or some recommendation on online shopping or e-commerce, usually we are dealing with multimodal data, right? Even though many studies still focusing on the interaction data or the textual description, but multimodality data would be becoming more prevalent and become more essential to handle. So here we show some very useful visual prompting techniques which can be used and adapted for the recommender systems. So the current current techniques is grouped as the visual prompting. For example, we extract the different bounding box, the markers, and the pixel level indications or the soft prompt to help us to prompt the VRM or some multimodal LLMs. And also the technique for how to generate the different prompts, like use some engineering, like use the pointing tool to generate the prompt or to indicate, and leverage the segmentation technique and detect. And another is the visual prompt can also help us to complete some perception and reasoning. For example, for this task is for the kind of navigation. So we can use the visual prompting to refine the landmarkers, to reason and generate the whole path to complete the task. And also the prompt learning techniques, how to develop more efficient and effective prompt learning techniques based on the current VRM or Llama kind of the models. So this is all the open areas I think we can try to dive into. Okay. Here is an example show beyond the NLP. So what kind of modality so how powerful we introduce some new interaction type. For this one, this is the example. Say the user, the A shows the purely language-driven interactive system, and the B shows the pointing language-driven. So let's first look at the figure A. So the users send a query, say upload the image, and ask the LLM to remove the boy in green pants. This is purely language-driven, right? Just give the language, and then the LLM needs to consume and analyze the text and find out which one is the boy wearing the green pants. So, and it's hard to detect, to locate. But if we can use some pointing language, for example, more interactive. So the user just simply click the target, the boy who is wearing the green pants. And the LLM is easy to locate, right, to process, and segment this target object and remove, right? So this is the results. So this is one application for supporting the multimodal query for the agent-based tasks. So this scenario is not typically for recommender systems, but you can simply imagine a scenario like the function recommendation, right? So we would like to recommend some outfit or some shoes, some different accessories for users. So you can simply just segment the point and mark and segment. So it's more easy. It's much easier than just purely language interaction, right? So I think maybe this would be another interesting direction we can pursue, especially for the mobile devices. We can easily point and also zoom in, zoom out on our iPad or mobile phone, right? So this would be very interesting topic. Yeah. So another, I think, a very promising direction, and currently my group also put lots of effort doing something. Hopefully we can report some outcome early next year. So about the alignment. So the alignment of LLMs has been extensively researched, but if we put it in the recommender systems scenario, so the alignment, the conception of the alignment can be generalized to the different aspects. So first is the classical one, the ethical. So we need to align the LLM, the agent, with the human values, like to maintain the fairness, diversity, unbiased, and unharmful, and safe, right? So especially, I think one typical example for bias in recommender system is the job recommendation. Maybe prefer to recommend some jobs like the more suitable to the female. But for example, for some professor job or some other STEM jobs, we prefer to recommend to the male applicants other than the female applicants. Right? This is a very typical bias in recommender systems, and also the political ideology. Right? If you are detected as very conservative, so maybe you will receive more posts and news coverage about that ideology. So this is to cause some information bubble or some chamber or something. So I think still in recommender systems, the alignment still can help us to solve this kind of problem. So for others, this is my personal opinion, like the temporal, because our human behaviors are highly dynamic. We're changing over time, right? We still maintain our core personality, but actually when we make choice, make decisions, actually still changing significantly over time. So how to align our behavior along the long temporal dimension? So we can use some maybe continual learning or some other technique to help us to continue fine-tune the LLM to achieve this goal. And also the behavior alignment and causal alignment and the preferences. So I would like to just mention the causality. So I think many of you already maybe came across some recent research about how to combine the causality with LLM, right? So recently there are two different ways. One is LLM for causality. Another is causality for LLM. My personal opinion, maybe LLM for causality would be more intuitive and maybe for us it should be provide us more solutions and different perspectives in solve the recommender systems problem, because our decisions, our choices, always driven by our intention or some other factors, right? How to establish this causality and leverage it in the agent would be a very interesting and I think very plausible direction to explore. Yeah. Okay, so that so for this slide, I would like to share some of the technologies, how to achieve the alignment. Let's first recall the very seminal work, the very famous one, the Instruct GPT. So this is very successful work to leverage the reinforcement learning from human feedback to the GPT model, significantly improve the performance of GPT. So for this process, it has 3 stages. For the first stage is collect some demonstration data and fine-tune the GPT model in a SFT as supervised fine-tune. Okay, so this technique have been widely used in the current LLM-related studies, agent related studies. And the second stage, with this fine-tuned model, we collect some offline preference data. For example, ask to develop some prompt, and several model parameters are sampled and put together, and ask the human labeler to mark which one he prefers or not. So to create some pairwise preference data. So this data set is totally offline, and this offline data will be used to train a reward model. And this reward model, so that's then heading into the second stage. So during this stage, we will have some new prompt, and that will be sampled from the previous one. And the policy and also the reward model will be fine-tuned. So eventually, in this paper, they implemented many different algorithms to fine-tune the RL, and it showed the PPO is the most effective one. But it depends. Maybe for your case, you can try the different ones. PPO maybe not the best. Okay, so this is the basic workflow for the RHF, for the alignment. So RHF is still the most popular solution for the LLM alignment. And the first equation showed the loss function. The first term is about the stage 2. So we need to train a reward model. Usually a logistic function is used, use the cross entropy. And the second term, so the KL divergence, just try to keep the policy not very far, deviate far from the previous the reference policy. So this is the basic framework for the RHF. So you can see lots of different variants based on that, but they still share the same principle. But for this work, for RHF, we can clearly see it inherits some limitations of reinforcement learning as well. For example, sometimes the reward model will be optimized and cause some unstable and overfitting. And also because we need to define the reward function, right? Reward model. So that means it's not possible for us to find a perfect approximation. It's always an approximation. So in this way, the researchers from Stanford, I think last year's Europe's best paper, they called the directive preference optimization, aka DPO. So this is a comparison I grabbed from their paper. So you can clearly see this skip the reward model step. So they can directly learn from this preference data, use the LLM and also its responses to the environment as the hidden reward model, right? So in this way, so just to create a more stable and more computational efficient approach. They also, in their paper, they also provided a very close formed theoretical framework to prove, yeah. And so the DPO currently the new emerging technique for the alignment. Maybe you can also have a look as well. So currently, yeah, so we are working on this part. Hopefully, yeah, can achieve something. And for the DPO, so we know without they directly map the loss function over the reward model to the loss function over the preference data. So it's very, it's more simplified and efficient, but also bring another new problem. That means it's totally offline, right? Because the preference data is prepared offline. So that means maybe in many cases it will cause some distribution shift. So how to solve this problem? This is come to some hybrid solutions or some. So for example, some papers they try to leverage the advantages of both sides of the solutions to deploy a aligned LLM or a different LLM to provide the online feedback for the online feedback for the policy training, and try to combine both of them together. And also, maybe if you are interested, you can look at the online DPO. They generalize the DPO from the default setting offline to the online setting. Okay, so it shows the better performance and the robustness as well. Okay, and that's why you just recall I mentioned just quickly. Introduce the reinforcement learning for Rexis previously, right? So actually they share very similar solutions and frameworks, the algorithms. So you can just, when you read this, if you are interested in the topic and the solutions, you can just put them together and to try to establish the connections. Maybe you can find some new perspectives and inspirations. Okay. This is a quick comparison between the RHF and the DPO. So yeah, I would like to mention one is ethical alignment here, because the DPO just mentioned is offline originally, so it's maybe not better to comparing with the RHF to align with the ethical and the human values, and also for handling the biases in recommender systems, maybe the RHF would be better than the DPO, because the DPO is totally based on the offline preference data, can to some extent to reinforce the biases to form the information bubble. Okay, so last I would like to quickly share another interesting research question. Yeah, currently we are also working. So it's about agent safety. So the safety is a two-folded conception. One is the privacy, another is the security. So privacy is, I think everyone knows that. So they call also the jailbreak in agent. So this just refers to the agent generates recommendations to the users and also pass some kind of the user's private information. Right. So so this is called jailbreak. It's also very interesting one. So yesterday I learned, I spoke with some of you, and their research topic is about federated learning. So maybe you can start to think about it, how to generalize the federated learning to the agent scenario. That will be from this year. I start to come across some papers to explore how to combine the federated learning with the agent case, not just the LLM. The LLM-based agent cases would be a very, I think, a blue ocean for you to create more impact based on your previous federated learning work. So I would like to introduce another one called the backdoor. So if you're familiar with the security or cybersecurity, the backdoor would be a very familiar concept. So it means to inject a backdoor into the model to make it behave normally in benign inputs but generate malicious outputs. Once the input follows a certain rule, such as being inserted with a backdoor trigger, it's based on the trigger. So it has been also extensively researched and explored in the cybersecurity and also the LLM as well. But I think in the agent scenario, there are some differences can just create some new research opportunities and challenges comparing with LLM-based backdoor attack or the traditional cyber backdoor attack. For example, based on the previous, we introduced the React framework, remember? To achieve a goal, actually it usually requires multi-turn interactions, right? So that means to achieve a goal, so it's for the agent cases, usually it is a multi-step intermediate reasoning processes. It's not a one time off. So in this way, we'll create more complexity. Yeah. Another is the agent can interact with the environment or the external tools, right? Not just so that means it can interact with other entities and in a more complicated scenario. So for the backdoor attack design and defense, you can find some different angles, right? To work. So I think this difference actually are good for us to just establish some new research topics, not just follow the previous ones, right? So here, this is a recent work. Just pre-printed, maybe not accepted yet, but it is very, very interesting work. They mainly focus on the backdoor attack, but the last one is salt attack. So they hide the trigger in the salt. That's they call salt attack. So it's kind of the typical backdoor attack in the agent scenario. Yeah. So I will leave you guys to read later. Yeah. So I think that's all. Yeah. So sorry for my accent. I always talk about.
Yeah, thanks very much, Lina, for this very informative talk. Now we do have some time for questions. So are there any questions from the audience?
Sorry for my accent. I'm also quite nervous. This morning, some student asked me, Lina, are you still nervous? I said, I'm quite nervous. Can't breathe. Sorry if my accent or something just make you feel a little bit difficult to understand. Maybe you can look at the slides. And also welcome to send me emails.
We do have a question.
Okay. Thank you. Until this talk, it didn't really hit me that recommendation systems can also benefit from large language models. So pretty good to know. And I think it's perhaps because on a consumer level, like on a really user level, what you expect from recommendation systems are sort of selection of items that are not necessarily, that don't necessarily require the text or the generation side of things. So I'm just curious, like, if more and more recommendation systems adopt large language models, would that imply that the interface needs to change? Or like, if the existing current interfaces stay the same, is there still a benefit to recommendation systems adopting large language models?
Yeah, that's a very good question. I think the interactions also involved with the advancement of LLMs as well. Just like mentioned, the example shows the pointing. Well, this is just one simple example. You can consider a more wild scenario, like the word VR, by introducing VR and also brain computer interface. Right. So you can put everything together that integrate with LLM more freely and more flexibly. Yeah, I think that is So this is some kind of real potential way for us us to study, because the LLM and the agent also brings some new, I think the new search in the CIRES, the CHI community, computer human interface. So they focus on study how to integrate, how to better team up between so with LLM based agents, so something like this. I think so one example I didn't mention here is about the things of interest recommendation in the IoT scenario. So it actually recommends us the real physical objects other than virtual objects. So it's, for example, if we cannot find our keys, maybe just if we combine with AR to form like the AR application, so we can help you to find the keys and help to guide you to, so I think, it's lots of interesting applications we can think about and try to develop. I'm not sure if this answers the question. But so far, I think maybe one step is to try to focus on the multimodality, especially for the visual signal, because the visual source is one of the major sources of human process and perceive, right? So, and also, and then we can expand to the audio as well, for music recommendation, right? And then gradually maybe head to more, enriched scenario.
So actually, I do have a question for Lina as well. It's more like a general question, because you mentioned the fairness and bias. That's a really important topic in recommender system research, and also probably for context for many of you who aren't really familiar with recommender system research. One important measurement for biases in the recommendation system is the performance gap between different user groups. So we want the performance gap to be minimal between the main user groups and minority user groups. But this is not always the case, because for minority user groups, you have less training data, so your model will perform less accurate in those cases, right? If you are a user who like watching action movies, there are a lot of interactions for the model to be trained, so it can be very accurate. But if you like documentary movies, unfortunately, there are less and less populations are into this type of movies, so recommendation accuracy will be definitely lower in that category for that minority user group. So when you talk about agent-based recommender systems, because they all use large language models as one of the backbone, and large language models are usually trained with huge amounts of data, and we call they have very good variety of world knowledge. So in your opinion, with large language models as the backbone, does that solve a part of the bias issues for minority groups, or does that actually worsen the issue? So because of the training data, the training process may strengthen the stereotype for some minority groups.
Okay. Thanks for the question. So I think we can solve this problem. So to try to correct this problem from different perspective. So one is try to create some more maybe unbiased data sets for fine-tune. This is one easy way to do. Another is through the alignment. Through alignment by using the human feedback to correct and to align the model with this problem, with the human values to conquer the fairness issue. Another way is just pop up in my mind the agent simulation. You mentioned the minority group has less data, right?
Yeah.
So we can use the agent to create and generate some more data, like augment the data to make it not a minority at all. Or but the condition is we need to define some very clear and justifiable generation rules to ensure the generated data also align with our requirements, not just make things worse. I think there's a different because it's the long pipeline for agents, right? So along this pipeline, there are lots of locations we can try to improve from data side LLM itself and fine-tune or something. Yeah, so, but I think with LLM should be better for us to address this issue, comparing with the traditional recommendation systems. Yeah, because we are working on this. Last year, we used we developed a method for the counterfactual generation to try to debias the data set used in the recommender systems. Yeah, so, and it's very successful, and we also deployed it, tested on the ARM-based method as well. So from early next year, maybe we'll have some results on the agent scenario. Yeah. So, and the fine-tune and alignment would be very interesting. Yeah, and a lot of, if you are fascinated with algorithms, try to do the causality and the alignment. So even though so the DPO and the RHF, all the things are very, very interesting. Yeah.
Thank you very much.
Salesman to sell.
Thank you very much, Lina, for giving me ideas for my next paper. So do we have? We can do one more question.
You talked about the bias related to the pipeline of the LLM. I'm asking about the privacy, because beside this bias, because when data is collected, it may be the bias affected on that, and also the privacy of the people, the data inside the system. What's happened to that?
So it's a good, tricky question. Let me think about it. Yeah, for the privacy, I think I mentioned the federated learning, right? So federated learning, because I'm not expert for FL, so don't laugh at me if I say something wrong. So for the FL, it can just keep the training, keep the training set locally collected and locally trained, right? So without the need to pass to the central server and maybe or to be broadcasted. Yeah, so I think this is one way to control the privacy just locally. Right? So another is you mentioned. Another is just to make use as it is. For example, if the user are very concerned about the data contains the very private information, so let's try to let's use some common filter out some information from this original data set. So in this way, maybe we will definitely lose some useful information, but we can make the user happy, right? So they're satisfied. So how to that is would be put a higher requirement for us to develop a more advanced machine learning model. We're given very limited data set, containing the partial information. We still can develop some recommendation models at the acceptable level, competing with using the full information. Right? This is also one thing we can do. We can try to make effort. Do not try to use as it is, or just read. So this is one way. Yeah, for others, and use some stimulated and synthetic data set. Yeah, so this is, I think this is shared some same principle like the offline RL, right? We can generate some synthetic data sets. So we assume, because when we generate it, we assign the rules to make it as similar as possible to the real scenario. But it's synthetic, we won't have any trouble in the privacy leaking or something, right? But this is cause a research problem like the distribution shift, right? If we can use some techniques in the offline or some other domain adaptation, domain generalization technique, so we can solve this problem from this angle as well. Yeah.
Okay. Lina, we do have one final question from Felix.
Just a quick question. Circling back to the beginning of your talk where you gave all these examples of Netflix and Amazon, etc. So what is, in your opinion, or do you have an insight of the distance between what Amazon and Netflix are doing and all the great techniques you showed? Because personally, I'm still quite underwhelmed by recommendations.
Yes, I completely understand. So the Netflix, why collaborative filtering became very popular 15 or 20 years ago, because Netflix launched a competition, right, to which method can best predict the movies to the users, right? So I think your current from Stan of Europe research scientist, he proposed, he and his team members proposed the correlated filter with the matrix factorization that achieve the best result.
Right.
So from that, so I believe Netflix still uses some CF-based method, but with lots of changes. Just like Google in the beginning used the PageRank, but they actually did significant changes, right? So, but still they keep some part of still working there. And also for Amazon, one of my students working in Amazon as a research scientist. So focus on recommender systems. They use the LLM and deep learning, but maybe not fancy as presented in the research papers. But they definitely
they're going there.
Yeah, going there, but maybe slowly because they also need some other extra requirements like stability and also some other concerns. So that's why maybe not so fast, but still gradually. But I think it's already happening.
Okay.
But because comparing with my conversation about 16 years ago with a guy from Alibaba, so we should go in Taobao, this very famous website in online shopping in China. I came across a guy from Alibaba at the CIRES more than 10 years ago. I asked him, so what kind of recommender systems are you using in your but I know there's a kind of commercial privacy or something. But he did mention a little bit. We found that the logistic regression is very useful. But back to them, we already started to use very fancy matrix factorization and probabilistic graph models to handle the recommender systems. And he told me, LR is quite powerful and useful. But in recent years, I talked with the industry guys. They started to use deep learning and LLM. So I think this is a great leap forward. Yeah.
Thanks.
Thank you.
Yeah.